We present a new lobe-based tree representation that is compact, easy to create, and efficient to transmit. It is well suited for interactive modeling and rendering of massive scenes. The lobe-based representation can represent tree data that is either acquired from a scanning device or possibly a CG model. The tree representation consists of two main parts. The first part is the skeletal structure, which is visually prominent and has to be represented faithfully. The skeletal structure is represented as a graph, with associated information such as branch diameter and textures. The second part is the crown geometry that is represented by a set of lobes, simple volumes whose internal structures are later procedurally generated through an operation called lobe texturing. For the input of a point set, the main branches are usually sufficiently sampled in the point cloud, while smaller branches and leaves are not sampled with the necessary density. The skeletal structures can be reconstructed according to existing methods as mentioned in the paper. The lobes are created using the alpha shape approach. The number of lobes can be controlled by the branch diameter, from which on lobes are constructed. This allows us also to control the size of the lobe-based representation. Classification is applied to the input data to determine the tree species. Following the spirit of patch-based texturing, we fill the lobes by combining small patches. In our case, these patches are small, predefined 3D structures called lobe-textures. The species library provides us with a set of lobe-textures for each species. Each patch has a number of seed points for connecting to adjacent patches. Lobe textures are selected according to their branch width, vertical angle, and proper fitting to the lobe geometry. The result is a convincing piece of 3D geometry. A variety of models can thus be represented with high fidelity. Here we show a re-representation of computer-generated tree models from the XFrog library. The visual prominences of these models are faithfully represented. The reconstruction and level of detail rendering of the main branching structure can be efficiently performed on GPUs. The entire process is automatic and allows the reconstruction of large urban scenes with massive amounts of trees. The point clouds are separated, classified, and converted into our representation with full automation. Large and dense scenes can be stored efficiently and transmitted in real time. Here is a large scene represented and rendered interactively using our method. Thank you for your attention.